Hey, good evening, guys. Good afternoon, good morning, whichever one you guys are deciding to watch this at. How are you guys doing today? Now we're going to go over the final portion now from the other video, continuing over which should be your standard normal distribution, which is basically your bell curve, z-scores, and probability and empirical rules. All right, we're going to go over that. I may not go into extreme detail when it comes to the z-score tables and things of that nature. You will probably learn that in statistics when you decide to take it. All right, so we're just going to go over the bell curve right now. And so, let me see if I can draw a really good bell curve for you guys here. Okay, let's just say that's a bell curve, right? And our bell curve here we have is equal, so the area of the bell curve, so you guys know, is equal to 1 meaning 100%, okay? So now what we're going to do, we're going to go ahead and try to figure out or understand what the bell curve is, all right? So the bell curve is a spread of data that's given, okay, based on the information you are given in a problem or when you're understanding statistics in terms of percentages and outliers and things of that nature. Like, there's so much to go into it, but I'll give you a very basic understanding of it right now. Okay, when you're ever talking about normal distribution, it's always going to be in this notation, x, all right, and it looks like the Harry Potter end there, okay, and then it's going to be your mean and then your standard deviation, okay? Now, in order to solve all these things, there's going to be a few other formulas you're going to need to understand, and then you're going to have to find your z-scores, right? And your z-score value, in order to find your z-score, you're going to take your x minus your mean, and then you divide that by your standard deviation. Also, whenever you want to find your x values, right, it's going to be equal to your mean plus your z-score times your standard deviation. Okay, now these are different formulas that will help you figure out, word problems, because most of these things are given in a word problem format. So I'll go ahead and explain more over into that. So when you have your mean here, right, your mean is the center, all right? Anything on the right side of your mean is a positive value. Anything on the left side of your mean is going to be a negative value, all right? And then there's divisions of your z-score or your standard deviation. So one standard deviation away from the mean on your right side is represented by 1, and then obviously the standard deviation sign, okay? And then it would be on your left side, it would be -1, okay, -1, okay? And then 2, you would get 2 like right here, all right? You would get 2 standard deviations there, all right? And then 3 is like really close to 0, or really close to the line, which is right here. Right, this is negative values here. And then it's not close here, but you can get the gist here. So that's going to be 3 standard deviations there. All right. And I'll go ahead and move this formula down a little bit for you guys, or maybe I'll just shift it up here for you guys to have it. So in order to find your x value, you're going to take your mean plus your z times your standard deviation. Okay. All right. Now, the z-scores for each different standard deviation is represented by the values that they're given there. So your z value for 1, it would be z equals 1. This would be z equals 2, and this would be z equals 3. Okay. And then the same thing for this one. You're gonna go z equals -1, z equals -2. And then z equals -3. All right, so those are your z-scores. And I'm not going to get too much into the z-score aspect of it in terms of the table. Like I said, you'll learn that in your statistics class next year if you decide to take it. Now, I will go ahead and go over certain other things that it correlates to everything that's going on here. So when it comes to the empirical rule, all right, the empirical rule states that between 68% of the area of the mean exists within 1 standard deviation of the mean. So between -1 and 1, you have 68% of the area there, or the bell curve that exists there, okay? And then 95%, right? 95% of your bell curve lies within 2 standard deviations, okay, of your mean. Okay, so you're gonna go ahead and get 95 here. Okay, and then 99.7% of your bell curve lies within 3 standard deviations. Okay. And this is what the empirical rule states. Oh, sorry, 99.7, not 98. Sorry about that. So 99.7. Okay. Now, in order to understand what's in the area here of your bell curve, like I said, the total area of your bell curve equals 1. But in order for me to figure out the values of each one, I have to do a little bit of math. All right. So in between these two here, it's 68%, correct? So what I have to do, I'll just take 68 and divide that by 2 because there's two different divisions here on each side of your mean, correct? So if you take 68, you divide it by 2, you're going to get 34%. Okay. Okay. Now, within 2 standard deviations, what you're going to do, you're actually going to take 95 minus 68 and then divide that by 2. So if you take 95 minus 68, okay, you're going to get 27. And you take 27, you divide that by 2, you should get 13.5. So right here, you're going to get 13.5%. All right? And then you're going to get 13.5% here. Okay? Now, the next one, if you can figure out now, you're going to take, within 3 standard deviations, you're going to take 99.7 minus 95, I'm sorry. So you're going to get 99.7, and you're going to minus that by 95. You're going to get 4.7. You divide that by 2. You guys should get 2.35. So in 3 standard deviations, you're going to get 2.35%. Okay, so right here, you're going to get 2.35%. Okay, and then this is your outliers here. That's at the very end, right? Your very end. In order to solve that, you're going to take 100 minus 99.7. So 100 minus 99.7, you're going to get 0.3, and then you divide that by 2 again, and then you're going to get 0.15. So this entire area here is 0.15%. All right, so you're going to get 0.15% here. Okay, now that is the understanding of your bell curve and actually how to divide all of its areas in the entire bell curve. Like I said, the empirical rule is 68% lies between 1 standard deviation, 95% lies between 2 standard deviations, and then 97.7% lies within 3 standard variations. And then the outliers are like, it's a rarity. Those things are like anomalies and things of that nature. So, which is the 0.15%. Now, I'm going to go ahead and give you guys some functions to solve, some really easy functions. We're going to do some like word problems, and then we're going to go ahead and actually go in depth and solve our bell curve. All right, y'all. So today, as you can see, I went out and wrote an example for you guys. Now, I didn't make it look like a word problem, but I just wrote it out like this. Usually it'll be like a long sentence or whatever, but I'm not trying to do that right now. All right, so based on this information given, it's saying that given x of n, where here's your local points there, 50 and 10, that is your set point. A, what is the mean and what is your standard deviation? All right. B, what is the value of x at a z-score of 1.4? And then C, what is the z-score that corresponds with the x value of 30? All right. Now, it sounds difficult, but it's really not that bad. The first one's actually really easy. Part A, and I'll write it in different colors for y'all. All right, part A, it's asking what is the mean and the standard deviation. Okay, part A, we're solving part A. Now, if you guys remember, right over here, right, it says that your mean is your first value here, and then your standard deviation is your second value. All right, so that's pretty easy. A, you got your mean equals 50, all right, and then your standard deviation equals 10. Job done. We figured out part A. All right, now we're trying to solve for part B. Part B says, what is the value of x at a z-score of 1.4. Now, if you remember here, this is the formula we're going to use right here, right? This formula right here, right? X equals the mean plus the standard deviation times the z-score, all right? So we're going to get your x value, which we don't know yet, but we know our mean. Our mean is 50, okay? Now we're going to add that to what is our z-score? Our z-score is 1.4, right? Put 1.4, and then multiply that by our standard deviation, which is 10. Now, if you multiply 1.4 by 10, you guys should get 14. So this is going to be 50 plus 14 equals the value of 64. So therefore, part B equals 64. So your x value, right? So your x value When your z-score is 1.4, the value is 64. All right. Now part C, we're going to go ahead and solve. See, as you can see, this is not that hard once you're able to understand what you're given. Part C asks, what is the z-score that corresponds with the value, x value of 30? So now it's asking you to find the z-score, right? What is the z value? Now we know the z value is right here. How do we solve the z value? The formula is right there for you. And I drew it here for you guys here. So this is your reference box, right? All right, so we're going to take z equals, all right, you're going to take x. Your x is what? Your x is 30. Okay, so 30, all right, minus your mean, which is 50. Okay, and then you divide that by your standard deviation of 10. Okay, so therefore 30 minus 50, you're going to get negative 20 divided by 10. All right, and then once negative 20 divided by 10, your z-score equals negative 2. Okay, so really simple way for you to understand a certain type of problem they may ask. All right, and based off this information, you have your little cheat sheet right here. You're able to solve all three, and it's really simple. Now, sometimes they may ask you, like, what is the difference? Okay, like, what is the difference between, you know, positive and negative values, right? Or the positive and negative z-scores, right? And the only thing you would tell them is that if you were to draw a number line, right? Let me draw this number line like right here, right? And then you have 50 in the middle, right? And then you have 30 here, and then you had 64, right? Those are your different x values, right? And based off this information here that you got from here, what is the relationship, or what is the difference between your negative values and your positive values? Well, we know that whenever you got a negative value, your negative values were always less than the mean, right? Your z-score was always less than the mean. And then your z-score here was 1.4, right? So we know that every x value that was less than the mean was a negative value, and every value that was greater than the mean was a positive value. So that's a question they may throw at you. I mean, I don't think they really will, but it may pop up here and there. But that is a very simple, easy type of formula or problem that's given to you when it comes to standard deviation and normal distribution. Here today, now I have a longer example for you guys, and this one's going to go ahead and explain in more in depth of how to understand the bell curve. All right, now the question says that there's an average test score of 74% with a standard deviation of 8. There are 2,000 kids that are in this class. Use the empirical rule to solve each one of the questions. All right. Now, what I did here, I already drew out the bell curve for you guys, right? And just so you know, the area of this bell curve equals 1 already. All right. And 1 represents 100%. So I'm going to go ahead and explain in detail what exactly we're doing here. So we said that the average score is 74. So that is our mean. Our mean is 74%, right? That's the average score, all right? With a standard deviation of 8. So that means every standard deviation that shifts over is going to be subtracting or adding it by 8, all right? So one standard deviation that moves over to your right, it's 74 plus 8 equals 82. When it moves to the left, it's 66, all right? If you add another 8 to 82, you get 90. Another 8 to 90, you get 98. Subtract 8 from 66, you get 58. Subtract 8 from 58, you get 50. All right. So the first question asks, part A says, what is the percentage of students that score less than 58? All right. And that's a less than sign. All right. So you guys know. All right. So part A, we're trying to understand what is the probability that a student scores less than 58. That's what it's trying to ask. So all you're going to do in this question here, all you're going to do is actually take everything that's less than 58 and add it together, the percentage. All right. So what you're going to do, you're going to take 2.35, which is here. This is less than 58, and then also 0.15. You're going to add those 2 points together, right? And then so when you add everything together, you get 2.5%. So 2.5% of the student population in that class, equal or scored less than 58%. All right. Now, if I asked you, well, how many students actually did score less than 58%? All right. All you're going to do is take, 2.5 and multiply that by the 2,000 students. But it's not just going to be 2.5. Remember, it's represented by 1. All right. So it's going to be 0.025. All right. So you're going to take 100, or I'm sorry, not 100. You're going to take 2,000 students. All right. And multiply that 0.025. All right, and that should give you your answer. So 2,000 students times 0.025, you should get 50. So 50 students scored less than 58% on the exam. All right. Second part here, I'm gonna go to part B now. Part B says, what is the probability that a student scores between 66 and 82%? Now, 62 and 82 is right here, all right? So what is the probability they score between 66 and 82, right? All right, and now all you see that it's 34%. So within one standard deviation of the mean, it equals 68%. Remember the empirical rule? That's what the empirical rule said. So now you're just gonna get 34 plus 34, which gives you 68, right? Which is the first part of the empirical rule. 68% of the existence of the bell curve, or the average of the bell curve, is one standard deviation from the mean. So you're gonna get 68% here. So 68% scored between 66 and 82. And you would use the same logic here if I asked you guys, well, what is the probability, or how many students actually scored between 66 and 82? You would just take 68% and multiply it by 2,000 students and you get your answer. All right, part C. Now part C asks, how many students scored at most 90%? So at most 90% is everything up to here, including 90. So it's the probability that they score less than or equal to 90%, okay? All right, so you can take all of these percentages and add it up together, right? Which would be 0.15 plus 2.35 plus 13.5 plus 34 plus 34, all right? And then plus another 13.5 plus 13.5, all right, that's a lot, all right? So if you add all those up together, you would actually get 97.5, I believe. All right. Yeah, you should get 97.5. Yes. All right. Now there's an easy way to solve this, and actually you don't have to add up as much. All right. And I'm gonna erase this here. Right. And all you need to do is write it differently. Right. Right. If I want to write it differently, you can also write it as, what is the probability that a student scored greater than 90%? Greater than 90%. So everything that's here, that doesn't include 90, all right? So everything that's here, right, on this side of the graph, right? But you're not done there, okay? It's not just that. I mean, well, technically, yes, that's all. It is just that. But what I'm saying is not done there, you're gonna take 2.35 plus 0.15, which is here. These are the outliers, right? So everything that's greater than 90% is 2.35, and then the outlier of 0.15, right, which you get 2.5, right? What you're gonna do, you're gonna take the 2.5% and subtract that from 100. So 100 minus 2.5 equals 97.5. All right, so you still get the same answer regardless. All right, so like I said, you could do it two ways. You could do it the other way where you add everything up together, or this way where you just add up the ends, right, and then subtract it from 100%. So either way you can do that. All right, but like I said, if they wanted to know how many students actually scored, you would take 97.5% and then multiply that by 2,000, and that should give you like 1950. Let's see, so you get 2,000 times 0.975, because 97.5%, 2,000 times 0.975, and yes, you do get 1,950 students scored at most 90% on the exam. Okay. Now, the next question's asking, part D is asking, what's the percentage that scored at least 66? So now it's like this. What's the probability of a student scoring at least 66, right? Now everything's greater, so the lowest you can get is 66, so that's greater than or equal to. So now you would add everything up from here all the way over here, right? So all this together here, you're gonna add together. So you're gonna take 34 and 34, which gives you 68, right? 34 plus 34, right? And then plus 13.5 plus 2.35 plus 0.15. That should give you 84%. right? 84%. 34 and 34, 68. 68 and 13, all right? 68 and 13 is 81 and 81.5, right? And then plus 2.35, which is 82.85 plus 0.1, I'm sorry, 83.85, and then plus 0.15 would give you 84%. Okay? That one's relatively simple. All right, and then part E, which is one of the easiest questions. They put E and A are really easy. How many students scored more than 98%? Well, 98% is right here, this outlier here. So anything that's greater than 98%, probability that a student scored greater than 98%, you're looking at 0.15%, and that is your final answer. Right, so this is relatively easy. I don't think I have enough time to go into the actual Z chart for you, which gives you like more in depth. You will learn that in statistics when you guys decide to take statistics next year, or maybe the year after that when you're a senior. All right, but you know, this is your lesson for today, and here we have a message from our sponsors.
Huh? What are you listening to? Brand new. Not even out yet. He's a friend of mine, you know her.
What's good? Yo, dog, understand me, say? Understand me, attack.